Hello everybody, welcome to week 3 part 4. In this part of week 3 presentations we are going to talk about a process called operator overloading and how you can use that to build available classes. One example of an overloaded operator built into C++ is the cout operator, or the less than, which is used both as a stream insertion operator and as the bitwise left shift operator. So C++ overloads the addition operator and the subtraction operator to perform differently, depending on their context in integer, floating points, and pointer arithmetic with data of fundamental types. You can overload most operators to be used with class objects. The compiler generates the appropriate code based on the types of the operands. Operators provide a concise notation for manipulating string objects. You can use operators with your own user-defined types as well. Although C++ does not allow new operators to be created, it does allow most existing operators to be overloaded so that when they are used with objects they have meaning appropriate to those objects. Operator overloading is not automatic, so you must write operator overloading functions to perform the desired operation. An operator is overloaded by writing a non-static member function definition or non-member function definition as you normally would, except that the function name starts with the keyword operator followed by the symbol for the operator being overloaded. For example, the function name operator plus would be used to overload the addition operator for use with objects of a particular class or enum. When operators are overloaded as member functions, they must be non-static. And the reason for that is they must be called on an object of the class and operate on that object. So to use an operator on class objects, you must define overloaded operators functions for that class with 3 exceptions. The assignment operator may be used with most classes to perform member-wise assignment of the data member. So each data member is assigned from the assignment's source object on the right to the target object on the left. Member-wise assignment is dangerous for classes with pointer members, so we'll explicitly overload the assignment operator for such classes. The address operator or ampersand returns a pointer to the object, and this operator can be overloaded. The comma operator evaluates the expression to its left, then the expression to its right, and returns the value of the latter expression. And keep in mind that most of C++ operators can be overloaded. These are the operators that cannot be overloaded, are listed on slide 3. You cannot create new operators, only existing operators can be overloaded. The meaning of how an operator works and values of fundamental types cannot be changed by operator overloading. For example, you cannot make the positive operator or the plus sign operator subtract 2 ints. Operator overloading works only with objects of user-defined types or with a mixture of an object of a user-defined type and an object of a fundamental type. Related operators like the plus and a plus equal must be overloaded separately. When overloading these type of operators or any of the assignment operators, the operator overloading function must be declared as a class member. For all overloadable operators, the operator overloading functions can be member function or non-member functions. A binary operator can be overloaded as a non-static member function with one parameter or as a non-member function with two parameters. One of those parameters must be either a class object or a reference to a class object. As a non-member function, binary operator must take two arguments, one of which must be an object or a reference to an object of the class. You can input and output fundamental type data using the stream extraction operator and the stream insertion operator. C++ class library overload these binary operators for each fundamental type, including pointers and char strings. You can also overload these operators to perform input and output for your own types. A unary operator for a class can be overloaded as a non-static member function with no arguments or as non-member function with one argument that must be an object or a reference to an object of the class. A unary operator such as not or exclamation mark may be overloaded as a non-member function with one parameter. The prefix and postfix version of the increment and decrement operators can all be overloaded. To overload the increment operator to allow both prefix and postfix increment usage, each overloaded operator function must have a distinct signature so that the compiler will be able to determine which version of the increment is intended. The prefix version are overloaded exactly as any other prefix unary operator would be. Dynamic memory management. You can control the allocation and deallocation of memory in a program for objects and for arrays of any built-in or user-defined type, known as dynamic memory management, performed with new and delete. You can use the new operator to dynamically allocate, for example, reserve, the exact amount of memory required to hold an object or built-in array at execution time. The object or built-in array is created in the free store, also called the heap. The heap is a region of memory assigned to each program for storing dynamically allocated object. Once memory is allocated in the free store, you can access it via the pointer that operator new returns. You can return memory to the free store by using the delete operator to deallocate it. Obtaining dynamic memory with new. The new operator allocates storage of the proper size for an object of type time, calls the default constructor to initialize the object, and returns a pointer to the type specified to the right of the new operator, in this case a time. If new is unable to find sufficient space in memory for the object, it indicates that an error occurred by throwing an exception. Releasing dynamic memory with delete. To destroy dynamically allocated object, use the delete operator as follows. Delete PTR object or pointer object. This statement first calls a destructor for the object to which PTR points, then deallocates the memory associated with the object, returning the memory to the free store. You can provide an initializer for newly created fundamental type variables, as in double pointer equal new double open parentheses 3.14159 close parentheses. The same syntax can be used to specify a comma separated list of arguments to the constructor of an object. Whether an operator function is implemented as a member function or as a non-member function, the operator is still used the same way in expressions. When an operator function is implemented as a member function, the leftmost or only operand must be an object or a reference to an object of the operator's class. If the left operand must be an object of a different class or a fundamental type, this operator function must be implemented as a non-member function. A non-member operator function can be made a friend of a class if that function must access private or protected members of that class directly. Operator member functions of a specific class are also called only when the left operand of a binary operator is specifically an object of that class, or when the single operand of a unary operator is an object of that class. You might choose a non-member function to overload an operator to enable the operator to be commutative. The operator plus function that deals with the huge int on the left can still be a member function. The non-member function simply swaps its argument and calls the member function. Overloading the function call operator. Overloading the function call operator is powerful because functions can take an arbitrary number of comma-separated parameters. In a customized string class, for example, you could overload this operator to select a substring from a string. The operator's two integer parameters could specify the start location and the length of the substring to be selected. The operator function could check for such errors as a start location out of range or a negative substring length. The overload function can call operator the overload function call operator must be a non-static member function and could be defined with the first line, as you can see on the slide for the string operator function. And with this concludes week 3 presentations. Thank you.